Chapter 5 is about motion. Now, there are only 3 exercises in this chapter, which unfortunately doesn't mean it's doesn't have much in it, or it's not very difficult, because it is neither of those. It does have quite a lot packed into just three exercises, and I suppose the difficulty is understanding the definitions. Now, they're not so much mathematical definitions, they're more physics related. So the actual mathematics involved in this chapter contains nothing new. The first exercise, you'll see there's nothing harder than finding the gradient between 2 points or subbing into an equation. The other 2 exercises, 5B and C, they both involve calculus, but there's no new calculus. The calculus either involves differentiating or integrating. So nothing new mathematically. It's a pure application of the mathematical techniques and processes that you have learned. Okay, let's look at 5A. 5A sets up some really important definitions. Now, most of the questions that you will get will be problem style, worded questions. It's so important when you read the question that you are paying attention to detail, that you are noticing the difference in terms like displacement or distance, and I'll point that out as I go through. You might think their speed and velocity are the same, but you're going to find they're not. You can't afford to read velocity and be thinking, oh, that's just speed. You really have to pay attention to the detail and be aware, I guess, of the differences in terms or concepts. So let's start. 5A talks about the difference really between velocity and speed. So 1, no calculus in 5A, absolutely no calculus, whereas 5B and 5C are all about calculus. So back before calculus, we looked at finding velocity and speed. So let's make sure that we have a really good understanding about some terms that are relevant to calculating velocity and relevant to calculating speed. So things like displacement. So the first term I'm defining for you is displacement. And the displacement, so when you see the word displacement, please don't just think distance. Displacement and distance may not be the same. They might, but I think that if you get a question that's talking about displacement, they're going to probably have it set up such that it and the distance would have different values. So distance and displacement, it's possible to have different values. So what is displacement? Well, the displacement by definition is the position of a particle relative to a fixed point. Now in maths, our fixed point is often the origin. And we talk about where a particle might be with respect to the origin. So we're really only talking one dimension here. So we're either imagining we're going, for example, from the origin here, until I get my pen working, from the origin, or with respect to the origin, we're going in this direction, or we might be going in that direction. That doesn't mean you've got to be in this area. You could be going in that direction from up there. So, or we could talk about going in this direction or going in that direction. Now, like it says here, displacement has magnitude, which is just a size, and direction. And we get to choose. We get to choose what's positive and what's negative. What is the positive direction or the negative direction? And that's all we use to describe the direction. It's either a positive or it's a negative, or over here we might be saying up or down. And like I said, we get to choose that. And we don't change what we're used to. Because this looks very much like the x-axis, then we would say a movement to the right is a positive displacement, a movement to the left is a negative displacement. Now, so if a particle was to, let's do the most simple example. They start at the origin and it goes in a positive direction and it ends up here. We would say its displacement is 4. If another particle started here and moved in the positive direction and ended up here, why didn't that right? Yep, ended up here. Now this particle that I've represented with the green line, it also has a displacement of 4. And it's plus 4 because it's moved in the positive direction. The reason that it is 4 is because the displacement is the position of the particle relative to a fixed point. My fixed point is 0. It's basically where does the particle stop. So this green particle has displacement of 4. However, it's had a change in displacement of 7. A change in displacement. So now we've got to distinguish between displacement and change in displacement. Now that's what I'm saying about the importance of paying attention to small detail. Displacement by definition is the position it ends up in relative to probably the origin, as opposed to what was its change in displacement. Now you're going to see that change in displacement becomes extremely important just in the very next definition. So it's a change in displacement for the definition of average velocity. Okay, a particle, say another particle that starts at 1 and moves in this direction and ends up at -1. Oh, that's not very good, but you know what I mean. Started at 1, finished at -1. What do we know? We know that it now has a displacement of -1. That's its position. But its change in displacement is -2 because it went 2 units in the negative direction. Okay, hopefully that's enough. And we could be doing the same over here, moving a particle with respect to the origin up or down. And if we choose to call up positive, then any movement, even from here to here, we would say, what would we say about this particle that's gone from here to here? We would say its displacement is -1 now, but its change in displacement is +3. It's a positive change in its displacement. It's gone in the positive direction. If it's gone from down here at -4 up to -1. So hopefully that's got that sorted. Replay this as many times as you need to get that any little question you might have hopefully answered. And if you still have problems, note them, write them down and ask me about them in class. Let's move on.